Hello, in this video I will share with you the inspiration behind my nose cone and the steps I took in summary to develop the nose cone. It all started with this Peak of Flight newsletter. From that newsletter, it led to much more details on the Apogee website. So thanks to Tim Van Milligan for designing this rocket. When you read the details, the trick is the nose cone. Tim found on Thingiverse a CAD for a nose cone, and this is that CAD on Thingiverse. So you can see that this is more of a model that someone might use on their desk, and I downloaded this version. When you bring it into Tinkercad, which is a very simple, free, web-based CAD system, you can tell that this is 2 inches by 2 inches by 3.45 inches tall, and that is too small for my 6-inch rocket. So we go to Composite Warehouse. This is the airframe I'm using. The outside diameter is 6.17. So you make a simulated rocket airframe of that size. Copy that. Go over to this original design, and then you proceed to scale this until it is the right size. You get the idea. Once you've done that, then when you look at this, it's got a hole in it, so you can combine this solid and align it with this rocket. That makes this, and then you can group them, and that now makes this a solid component. Group those. So next we need to make it hollow like a nose cone would be. So I drew a hole that is subtracted from a solid. We'll talk about these little notches in a bit. But then you combine this hole with this by simply aligning it. Now it's underneath, and you can see the thickness of the rocket. So that gets combined, grouped, and we'll take a look at that in a minute. But as you continue, you'll see that this is 12 inches tall, and that is too tall for a 3D printer, so we have to cut it down into 2 pieces. So the natural place to do is to cut the dragon and the trunk, and I did this, you can tell as I work backwards and disassemble it. You can see that I simply lowered the dragon down to the surface of the work plane, took a big square and cut the trunk out, and that's how you create just the top portion. And likewise, I did the very similar thing with the trunk. You can just take a look at the trunk here real fast. Again, it has these holes, which we'll talk about later. But if you take apart the trunk, you can see that I just cut the top of the dragon off. Need to be able to put those two together, so I have a coupler. The coupler goes right in the middle between the dragon and the trunk. I was worried about just gluing these together, so I actually put some holes in for screws so that I have a mechanical connection as well as an adhesive connection. So this is the coupler, and that would again go inside. Now you can see there's all these holes. Well, you can see them here if I delete, deleted the whole thing. you can see these holes. These holes are precisely placed, and they generate the voids or the geometry where the screws will be inserted. Then we need to make a shoulder. The shoulder goes inside the trunk, and then these rings are the surface that interface with the inside of the rocket. The inside diameter is 6 inches. And if you take a look at this, those rings are 6 inches. They also have holes that can be tapped and used to insert screws to hold the nose cone to the frame. And there's lots of them, more than I'll use, but it just gives me options in the future. When it comes all together, it looks like this. First, starting with this is the shoulder. You can see the portion that goes up inside the trunk. You can also see that coupler again. Here's the trunk. And then you can see on the nose cone, you can see the thickness of the nose cone. This line represents the inside void, and this is the outside surface. It's nice and thick. That increases the durability, resistance to cracking and impact, which is covered in our durability video. And that is the final nose cone. It's printed in each of those parts and will then be assembled. Please let me know if you have any questions. Thanks for watching.